So continuation with respect to the previous mechanism. Further, we'll extend with different type of mechanism with respect to the inversions. So quick return motion mechanism. So how a crank and slotted lever quick return motion mechanism works is. So here if you take this is this type of mechanism, it is added in the shaping machine where there will be a crank which is going to rotate. So here the crank is going to rotate at a stipulated angle with respect to alpha and beta. It is got motion. So alpha is the return stroke and beta is the cutting stroke. Means the shaper mechanism only forward stroke is the cutting stroke and the return stroke is a not cutting stroke. So here there will be a ram and tool. So here it is going to make forward it will be the cutting stroke, return it will be the non-cutting stroke. So there will be a connecting rod. So here with respect to P1 and P2, this slider it is going to make the motion which is having a connecting rod to the ram. So this is the line of stroke where the cutting tool is going to advance. So here in the crank you can see alpha is there and 90 minus of alpha by 2 it is considered. So here the one is alpha, another one is beta. So alpha is the return stroke, beta is the cutting stroke. So here B1 and B2 are the angles. So B is the slider crank link 1. Crank it is got the link 2. So here it is going to make the rotation, right? So here this is what the motion is going to happen in case of the crank and slotted lever mechanism. So here beta, if you want to keep it in terms of alpha or beta, here you can reduce the expression. So here the line of stroke of the ram is R1 and R2, is perpendicular to AC. So here the extreme positions are AP1 and AP2. It is the tangential circle which is going to get generated. So here we can from the triangle with respect to AQP1. So here we will be able to calculate all the angles required. So you can consider the triangle here as per the diagram, and you can calculate the length of stroke. So that is R1 into R2, that is equal to P1 into P2. So you can take 2 P1 of Q, that is equal to 2 AP of AP1. So sine of angle P1 of AQ here it is considered. So here in the shaping machine, this is what here it is shown. Here animation it is not happening. So here the diagram it is shown. So further if you go with the elliptical trommel where there will be where there will be where the link 1 and link 2 it will be moving in this slotted plate. So here is for this is meant for drawing ellipse. So here if the slider link 3 if it's going to advance, then the slider link 1 it is going to move towards the left. So it is going to draw AP is the semi-major axis, BP is the semi-minor axis. Like this you'll be able to generate ellipse drawing on the surface by using elliptical trommel. So here models are there to show how exactly the trommel is drawn. So further if you go with the Scotch-Arc mechanism, in the Scotch-Arc mechanism you can see the link 1 it is fixed and the crank 2 it is going to rotate and the slider leads the link 3. So here it is the mechanism it is meant for converting rotary motion into reciprocating motion. So here the link 1 it is fixed. So when the link 2 crank rotates about point B, as the center reciprocates, reciprocating motion can be obtained. So further Oldham coupling is there where you can see two shafts are at different positions. So you can convert rotary motion from one place to other place. Here you can see A and B are the two shafts where A is the driving shaft, B is the driven shaft. So there will be an intermediate piece between the two flanges where it is going to transmit motion from one place to other place. So here this Oldham coupling it is used for connecting two parallel shafts whose axes are at small distance apart. So further we'll be going with the toggle mechanism. So in the toggle mechanism here you can see the alpha, it is the angle which has got inclination with respect to point O, and the point O and the another constraint where it has got with respect to link 4 and link 5, it has got equal angle. So here this type of mechanism, it is used in stone crushers where we have to overcome large resistance for a small force. So toggle clamping devices are meant for holding the workpieces. So this type of application is extended to the clutches and the pneumatic rivets. So here the force applied you will be able to calculate by using 2p into tan alpha. So p is the load where you are going to act on the slider. So here omega 2 is the is the velocity given to the crankcase. So and it is fixed at point A. So and it is going to rotate with the omega 2 speed. So the required force is applied the the required stone crusher, it is going to utilize the force to get the required work done. So intermediate motion mechanism, another one example is the ratchet and ball mechanism, where you can see ball is there, and the ball you can see when the shaft rotates, so there'll be a ratchet. So there'll be a ratchet which is going to rotate, and the ball what it is going to do is it is going to engage in the slot provided over there, so that it is going to utilize the space over there, and it is going to engage in the cutter point, so that it is going to stop mechanism intermittently. So locks, jacks, clockworks are some of the application where it is used for intermittent motion mechanism. So application, it is meant for hoisting machines where it is used as a safety measure, where we can use for lifting water from the well. So like this, we'll be able to utilize the required ratchet and ball mechanism. In the Geneva mechanism, once again, it's an intermediate motion mechanism where you can see, uh, like if the quarter of a circle moves, the advancement happens on the surface. Here it is show if it is going to engage on the surface where you can expect intermittent motions. So there'll be a pin on the slot. Every motion, what it gives, the pin is going to engage in the slot so that the motion is restricted, and it is held for some time to get the required output. So in the Geneva mechanism, what we can see once again, it shows it is applied to the chain mounted drive pin with blocks for locking during dwells.